Fabrice is talking about an experimental validation of a robust controller with a VAIMOS autonomous sailboat, and I'm looking forward to learn a little more about how that worked out.
So my talk will be about our process of validation of robust controller for sailboat. So for that we used the VAIMOS autonomous sailboat, which is a sailboat designed by IRSC2012 for the mechanical and electronics part, and Instabotile made the embedded and autonomous algorithms. So the goal of this sailboat is to make oceanographic measurements for scientists of IRSC2012. So the idea is to try to replace, or at least to help existing instruments that are used on oceanographic ships. For example, fixed buoys that are instrumented, floating buoys that drift on the sea, or towed instruments towed directly by the oceanographic ship. So here are some pictures of the sailboat. So the sailboat is less than 4 meters long. It has several sensors. You see on top of the mast the weather station, which is a GPS and wind sensor. We have a compass. We have several ways to communicate with the robot. We have Wi-Fi, we have an Iridium satellite communication system. Sometimes we install a spot messenger also. And last month we also added a radar reflector to be able to be seen by the radar of the oceanographic ship, and also a VHF emitter to be sure to locate it for recovery. So I can show you a small video of the latest test we made with it. So last month we were in the middle of the Atlantic Ocean on the Thalassa oceanographic ship, which is this one. It's a boat of more than 65 meters, and here we have a video of the deployment process of the sailboat from the Thalassa oceanographic ship. So we have a kind of crane at on the rear of the ship that put the sailboat, which is on a kind of floating structure. with Zodiac, people take the boat and then leave it on the ocean. So here it is autonomous. The mission has just been started, and we see the sailboat trying to start joining its desired trajectory. So this is the recovery process. So it is the other way around of the deployment process. So to make efficient measurements for the scientists, the idea was to try to make a sailboat able to cover an area autonomously and as accurately as possible, to be able to be left alone while the big oceanographic ship was doing other things with other instruments in the same time. So here is an example of a trajectory of VAIMOS when we were last month in the middle of the Atlantic Ocean. So in the beginning, on previous versions of the boats we had, we used a simple waypoints following strategy to make the boat follow a defined trajectory. So the main drawback of this strategy is that the sailboat just tries to keep heading in the direction of the waypoint, of the target waypoint. And the problem we had when we made tests is that most of the time, because of currents, for example, currents going like that, the sailboat was not following a line just between the two waypoints. It was most of the time drifting, maybe staying in the right direction towards the target waypoint, but making this kind of trajectory, which is not so accurate. And it would not produce the same. It would not produce this kind of trajectory at the end. So, to try to solve that problem, we decided to change our approach, and we decided not to try to follow waypoints, but try to follow lines. So, thanks to this approach that will be presented in more details in one of the next presentations, we were now able to do that sort of trajectory. So you see that even if sometimes the sailboat had to go upwind, the line following controller makes it stay in a predefined row of, for example, 50 meters around the desired line, the desired trajectory. So in green it is the GPS positions logged by the sailboat, and in red it was the desired trajectory. So before really testing this line following controller, we made some tests and some validation, and we used some validation methods to try to demonstrate that in all case of wind and initial positions of the sailboat, it will either always try to join the area between the line, and when it is already in the row of 15 meters width around the line, the sailboat will always stay in it. So we designed a simulator and even an hardware-in-the-loop simulator. So we had the embedded computer of the sailboat that was running the line following controller that was plugged in to a normal computer running a simulator that was producing simulated sensors data. For example, the heading of the sailboat, the wind direction, and the GPS position. And the inputs of the simulator or the real sailboat were the angle of the rudder and the maximum angle of the sail, which corresponds to the length of the cables that maintain the sail. So our simulator is based on state equations, which are just written here. And thanks to these state equations, we tried to run several simulations in different conditions to try to validate our line following control. So I can try to show you the simulator in action. So on this, on a simple example of a triangle near Brest Harbor. So the red lines are the desired trajectory, and the green lines that will soon. It just starts. Okay, so we put in the simulator an initial position, and then the sailboat with the simulated sailboat will try to join its line, to join its first line, which is that one. So in the simulator, I think I put a wind from the north. So we see the sailboat joining the line. I will leave it run a little bit and show you in the same time other simulations. For example, one of the first big tests we made with VAIMOS was a trajectory between Brest and Varadez in Brittany. So before making the real test, we made several simulations. Here is an example of one simulation. So we, depending on the weather forecast, especially the wind direction forecast, we tried several scenarios. For example, for this area covering, depending on the weather forecast. So here is an example, and we see here a zoom of one part of the trajectory, and we see that the simulator is able to show to simulate tack and upwind trajectory. Here is another scenario with, I think, a wind that was probably from the north. We decided to change the waypoints to optimize the speed of the boat in this area. back to the simulator. Okay, so now it has reached the first end of the line. In our line following controller, the condition of validation of a line is when we reach the perpendicular of the desired line at the target at the second waypoint of the line. So normally the next line should be upwind, and additionally, so when we are in real experiment, we have this kind of graphical interface to be able to know where is and what is doing, what the boat is doing. We have also another kind of dashboard that help us to know what happened on the robot. So, for example, here, this is what we can show from the log files of the sailboat. Here we just draw all the positions of all the previous position of the boat, and we can see whether the sail angle was correct, the rudder angle was correct. We can have an estimation of the speed, and we also draw the wind direction in black, and in green we have the target heading. So that helps us to monitor the behavior of the controller and to try to see if in that condition of wind and depending on the target line, is it normal? It is normal that the rudder and the sail has these angles. So now we are on the last line, and we see the tag for the last line. So this is only simulated data. Now I will show you some of the experiments, some of the real experiments we made. So first, we made small missions in Brest Harbor. So first, a small one of less than 8 kilometers, I think. Then a bigger one of 14 kilometers, with several wind and shape of desired trajectory. In the end of January, we made our first big experiment of more than 100 kilometers during around 20 hours. So during this experiment, we had a chasing boat like that, which is a motorboat of less than 10 meters long. During the mission, we had to prevent the sailboat from going in the path of several obstacles. So first obstacle, a submarine that was coming back to its naval base. So we had to take the sailboat with the Zodiac and make it change its path. So after we left the sailboat alone, it managed to join its line and continue normally. And here also we had to do the same for another boat. And the latest test we made was in the Atlantic last month, just in the middle. So I told you in the video that we were in a big oceanographic ship as a chase boat, and I can show you some of the trajectories we made in the area. So if we unzoom, you will see where it is. So it's really in the middle of nowhere. We were there. So our biggest mission was that one. It was not so beautiful mission because we changed several times the desired trajectory. So the idea here was to go several times on the same line to make measurements of the same area. So yes, okay. So if we zoom a little bit, we have first the first line that was there. Before it finished, we changed it to another line, and there was 2 or 3 small changes on the line, and you see if we zoom that there was several. The sailboat goes several times on the same, always in less than 50 meters around its line. Okay, so I think I finished. If you have any questions.
Thank you very much for that. It's really, really impressive to see this big boat and the small one, and know where it is. So, any questions regarding this? Well, experimental validation.
Really, really impressed. It's great. So you were measuring some ocean parameters.
Yes.
What were you measuring with? Were you towing a sond or?
So there was a probe on the sailboat which was measuring the temperature, the chlorophyll, the oxygen, and the salinity of the water at near the surface and also under the keel. So the purpose was to make some kind of comparison of the surface and less than 1 meter behind the surface. So we have a pump system in the boat that sometimes take water from the surface and sometimes from the keel.
Other questions?
So do you have that integrated with your control system? Are you relaying that data, or are you storing that data separately?
In fact, it is integrated on the same embedded computer, but the measurements are independent on the navigation on the navigation system. We just the only dependence is probably the desired trajectory that is decided to be in interesting areas. So, for example, here you have one of the trajectory of the boat with the color that corresponds to the level of salinity. So we see that I don't know what means the colors, but we see that here it's more yellow and here more green. So that's probably an interesting information for scientists of the boat. But I don't know so much this part.
So you have the ability. You could, in principle, autonomously change the area that you patrol.
Yes,
yes. Quite interesting feature.
Yes, that's why we changed several times the line.
So I think you guys have finished, so we'll stop working on this area.
No,
really impressive.
That's a very good concluding mark.
Really impressive. That's great.
I would say I managed, or thanks to two very interesting and entertaining talks, I have to say, we managed to even run over time, though we had one talk less. Colin, is it okay if we now shift the rest of the discussion into a break, or what's happening next?